Okay. By the way, when I record in the morning, there is never any issue with this wind. Sometimes a chopper goes by, as you have seen in some podcasts. So afternoon, the winds get very strong. There is a lake here, and there are buildings all around the lake. So there is obviously a lake-land breeze, I suspect, with a very strong diurnal cycle. And I suggested this as a nice research project, but nobody showed any interest. I think there is data to look at how the heating of the land around the lake and the relatively slower heating of the lake is probably creating some strong diurnal cycle in the winds. That would be a cute thing to look at, but people only want to look at things that lead to publications. Okay, so net zero CO2 and net zero greenhouse gas emissions are possible through different modeled mitigation pathways. This is kind of a capturing statement. Remember, this is a summary for policymakers, so often the headings are given as statements that are easily accessible and are carrying a good message or a clear message about what the figure is going to say. Again, looking at gigaton CO2 equivalent per year, we are looking at sectoral greenhouse gas emissions at the time of net zero CO2 emissions compared to the modeled 2019 emissions. So when the report was being written, 2019 was not available. So from some year before that, I suspect 2018 or 2017, 2019 was modeled, and that also allows them to then compare model 2019 projections to actual 2019 emissions and so on. So we are looking here again at various sectors: buildings, industry, transport, energy supply, positive and negative, so land use, land change, and non-CO2 greenhouse gases from all sectors. So there are indirect and direct emissions. So this is total direct energy emissions and total indirect energy emissions equals sum of energy equals sum of energy supply emissions. So details are there, but the main message is that when we look at these 2019, we had this contribution from energy supply and various other sectors like industry, buildings, and so on, and non-CO2 emissions. At the time of net zero, we have to be in this range here. So land use obviously will be negative. Energy supply has to be net negative as well. Renewables plus carbon capture and sequestration, like in the case of bioenergy, for example. And then there will be some positive energy supplies, and there are some irreducible emissions from transports, industry and buildings, and the non-CO2 greenhouse gases. These are illustrative mitigation pathways, GS, negative. I think this is a low use of resources. This is sustainable pathway. This is renewable, and so on. So I obviously didn't go into the details of the scenario assumptions, but you can see how the range changes here based on which mitigation scenario is used for future projections of greenhouse gases at net zero year. So this is obviously lower than this one, which is higher than this one, and the sustainable one is the best one in terms of higher negatives and lower positive overall. This one these have higher negatives, but they also have much higher positives here in terms of sources and sinks of gigaton CO2 equivalent here. Okay, so this one has lots of non-CO2 emissions, for example, and the others from buildings, industry, and transport have been squished to be smaller than here, but the negatives are smaller as well, and land use, land changes smaller negative here than here or here. So obviously various levels of assumptions go in. Without going into these details, we are saying that these are possible with these modeled mitigation pathways. And obviously you cannot give just one scenario, you have to give a range of what if scenarios for the future. These are percentage of modeled 2019 emissions at net zero. So contributions to reaching net zero greenhouse gas emissions for all scenarios here to reach net zero greenhouse gas emissions. This is contribution by sector, and this is total direct and indirect, and this is from land use, CO2 and non-CO2. So this is the total zero you want to accomplish with respect to 2019. So parts will come from buildings, indirect and direct contributions from buildings and transportation and industries. Okay, and these are total direct and indirect, so sum of these and these together, and this is separately from land use change. So these obviously include things like natural climate-based solutions, management of agriculture, reducing emissions there, and so on and so forth. So again, without going into details, it gives you a sense of what is envisioned in terms of modeled pathways to reach net zero and the contributions from various sectors. Okay, so the demand side mitigation can be achieved as well through changes in socio-cultural factors, infrastructure design and use, and end-use technology adoption by 2050. There's a lot of literature on socio-technical transitions and the barriers in terms of knowledge, institutional barriers, policy barriers, financial incentives, and so on. Keeping all that in mind, socio-cultural factors, I have podcasts, for example, on whether social transitions can be triggered, a regime shift in social transitions can be triggered, and so on. So those kinds of details are always interesting to understand, because we are here now mixing physical models, natural science models with socioeconomic models and social science models. So it's kind of a mishmash of integrated assessment models with different levels of uncertainties and assumptions. So this is divided into nutrition, manufactured products, mobility and shelter, and electricity indicative impacts of change in service demand. So food includes nutrition, infrastructure use, and end use technology adoption. In industry we have manufactured products and other details like infrastructure use and end-use technology adoption. My reading ability has degraded here, obviously. And under land transport, mobility, and under buildings you have shelter, compact cities, energy efficiency, and under electricity you have additional electrification and so on. Okay, so here are again various sectors like AFOLU, which is agriculture, forestry, and other land use, direct reduction of land related emissions, and so on and so forth. Lots of details here, but you can see under food, gigaton CO2 equivalent, again to go from where we are to where we need to go. So socio-cultural factors are expected to add, like dietary shifts. How are they going to be accomplished? Not always clear, and the uncertainty here is quite large as well. And avoidance of food waste and overconsumption. So some are no regret decisions like reducing waste may be easier to convince people to adopt than dietary shifts. For example, if people love to eat their meat or they don't want to be vegans, you cannot force them to be. There are cultural issues and so on and so forth. And there is infrastructure use that can give some reduction, and the rest has to come from basically land use and so on. Okay, so just make sure all the legends are followed properly. Okay, so under manufactured products, mobility and shelter, again, what is the total that needs to be accomplished, and what will be the contribution from sociocultural factors, infrastructure use, end use technology adoption, and the emissions that cannot be avoided or reduced through demand side adoption. Demand side options are assumed to be addressed by supply options. So these are irreducible emissions that have to be addressed by supply side. So this is only demand side mitigation. Human settlements again, and this is the buildings. Okay, so gives you a sense of how detailed the computations are. In electricity, here you are expecting the significant change in additional electrification, sociocultural, so this is mostly additional electrification, which is similar to social cultural. So this is a direct reduction of food related emissions, buildings emissions, and so on and so forth. So very complicated. So this is all electrification. Sorry, I mixed it up a little bit. Okay, so and others here, industry, land transport, buildings, and land management, and the irreducible demand side measures. So that is demand side measurements of totally minus 73%. So the rest is going to be irreducible and will require supply side reduction. So you have people manufacturing, transporting, and selling goods and using energy and emitting on their side, and there is the demand side. So this is modeling pathways on the demand side mitigation. Okay, let me stop this here and look at the options available already in all sectors with substantial potential for mitigation. This is a big question in terms of putting out optimistic messages. By 2030, can we accomplish a lot of mitigation by existing technologies, or do we have to wait for new technologies and new game changers to come along? So the next one looks more optimistically at what is available and how they are already able to contribute to these mitigation pathways. Okay.